Hello viewers, welcome back to another session of my Bernoulli equation tutorials. In this video, we're going to solve a volume flow rate problem. Volume flow rate. So let's see what the question is. It said a 6 centimeter diameter horizontal pipe gradually narrows to 4 centimeter when water flows through this pipe at a certain rate. The gauge pressure in these two sections is 32 kilopascal and 24 kilopascal respectively. What is the volume flow rate? What is the volume flow rate? So let's see how you're going to solve this problem. So first of all, since we are going to apply Bernoulli's equation, you have to first take the Bernoulli's equation down. So our first pressure. So let's first sketch our horizontal pipe. So realize that the first diameter is bigger, with a 6, and it narrows to a diameter of what? 4. So let's say this is a 4 centimeter part and there is a 6 centimeter part. So here we're going to have one pressure here, the velocity here, then also so pressure and also the velocity as we have here. So from the equation I have P1 plus rho hg rho h1g plus half then rho v1 squared should give us P2 plus rho h2g plus half rho v2 squared. Now we are considering a horizontal pipe. Obviously the change in height is 0 because the height at one point and the other points are the same. So this thing will be out of our equation. So therefore I'm going to have the change in pressure at one side and change in velocity at also one side. So I'll have P1 minus P2 to be equal to the half rho open bracket V2 squared minus V1 squared, like this. So now you ask yourself, what is volume rate of flow? Volume rate of flow. So when you are dealing with volume rate of flow, then you're going to consider the product of area by the velocity of the fluid, area of the cross section by the velocity of the fluid. So let me put it down. So the flow rate, let's say Q is equal to area times the velocity. So right now we need a change in velocity, then also we find the area as well. Now in the Bernoulli's equation we can have area anyway, but we can find the change in velocity in that. So from here what you are going to do is you make change in velocity the subject and you are going to get P1 minus P2 multiplied by what? 2, and this should be equal to rho V2 squared minus what? V1 squared. So I'll make V2 squared minus V1 squared the subject, and this will be giving me 2 multiplying. So our pressures, I'm going to have 32 minus what? 24, everything over what? Rho, and rho is the density of water, which is 1000. Then don't forget the pressure is also kilo, so 10 to the power 3. So this should give us 32 minus 24 is giving us what? It's giving us 8, right? Yep, so this will cancel the what I have here. Therefore my change in volume here is going to give me 16. My change in volume here is going to give me 16. So let's see how we're going to do this. Now let's see, to find the area or from Q is equal to AV, we need area, right? So you can see that you have two area or two, since the diameters of the cross sections differ, you have area 1 and you have area 2. So considering area 1, we are going to have the diameter, which is 6, so 1 out of 4 pi d squared, right? Then 1 out of 4, so this d1 d2 pi d2 squared. Then this 1 out of 4, and multiply and solve this. So our diameter is simply 6. So if I convert 6 to meters, I'll get 0 points. Just divided by 100. So 6 out of 100. So I get 0.06 all squared, right? Then here to 1 out of 4 multiplying pi. Then our diameter is what? 0.04 all squared. So I need the area of these two parts. So therefore, I'll get so at this point, I'm going to get area 1 to be equal to 0.25 by 0.25 multiplying pi 3.142 then by 0.06 squared. That will give me, let's say, 0.00283. Then that of this side, 0.25 times 0.142 by 0.04 squared, and that would also give me 0.00126. I have the two areas now. Then what am I supposed to do? So from here, from this side, we have Q is equal to A and V. But since you have two different areas, we can also find our change in velocity at this side once again. So let's see. You can see that velocity from this side is going to give us what? Q over what? A, right? Yes. So when I put this into this, I'm going to get Q, that is for one part, Q1 squared or Q squared, let me Q squared over what? A1 squared. Then I'll get other part to be Q squared over what? A2 squared, where the area 1 and area 2 are V1 and V2 respectively. So my change in velocity in terms of the area is going to give me Q, which is Q squared over A2 squared minus my Q squared over A1 squared. Now this should give us our V2 squared minus V1 squared. That is, we are equating the change in velocity. That's the only thing we are doing here. We are equating the change in velocity. I can factorize my Q squared, which is my volume rate of flow. So my Q squared out, I'm going to get 1 over A2 squared minus 1 over A1 squared. And this should be equal to V2 squared minus V1 squared. We got it from the Bernoulli's equation as 16. So this should give us 16. Then what am I supposed to do? What I'll get here, then I'll divide 16 by that. So that will give me my Q squared. Then after, I'll take the square root also. So I already have my areas, but I have to put it here. So Q squared, then 1 out of 0. So I have my A2. So for the diameter, which is 0.06, that is giving me this 0.0. So for the diameter 6, it is giving me 0.00283. Then all squared minus 1 out of 0.00126 squared. But we make sure we don't get negative here. So 1 out of 0.00283 squared minus 1 out of 0.00126 squared. So I'm getting, yes, so I should have interchanged it rather, yes, so I'm getting something here. So once I have this, I'm getting Q squared, then 5.05020, because the diameter was very small, that is why it has affected this. So when I get this, it should give me 16. and I divide through. So 16 over what I have, 505020. Then I take square root of that to give me my Q. Square root of this 16 over 5050, then 20. So that is giving me my volume flow rate is simply equal to 5.63 times 10 to the power negative 3. So that is volume, so meter cube per second, right? Exactly. So this was an application of both Bernoulli's principle and also you just apply some logic somewhere here. This is the end of our video. Thanks for watching. Kindly subscribe and also like.